Hi and Assalamualaikum everyone. My name is Ami Najwa Firdaus binti Cik Abdul Kadir. My ID number is 5110-2324-133. So today I would like to present about the concept and operation of ABCD to 7 segments in digital electronics. So for today's agenda, I would like to discuss about first the introduction of the BCD to 7 segment, and then the function, the block diagram, the truth table, the conversion process, the application, and lastly the conclusion. So here is the introduction to binary coded decimal, which is BCD. So first, BCD is a class of binary encodings where each digit of a decimal number is represented by a fixed number of bits. Usually, it is 4. So it uses binary values from 000, which is the decimal number is 0, to 1001, which is the decimal is 9. So here is the crucial technical note, which is states from 1010, which is the number 10, to 111, which is the number decimal 15, are invalid, or which we say don't care condition in BCD. So next, I'm going to talk about the function of a BCD to 7 segment decoder. So what is its purpose? So it is for bridge the gap between the digital systems which operate in binary and human display interfaces. So the operation, it takes a 4-bit BCD input code and it converts it into the appropriate electrical signals to drive a 7-segment display. So next, the display elements. A 7-segment display consists of a 7 LEDs pattern labeled A through G. So I would like to show in the next slide. So here I would like to show you the system block diagram. So here is the BCD to 7-segment decoder. So in the left side, we have the BCD input, which is from the most significant bit, which is A, B, C, D, which is the D is the least significant bit. And then at the right side, we have the 7-segment outputs. We have the A, B, C, D, E, F, G. So as you can see, that is the 7 LEDs which we are going to show the number from 1 to 9. So next, here is the truth table. So in the truth table, you can see which lines is high and which one is low, so that it would display whatever number that we would like to show. So for example, we have the display pattern of the 0. So for 0, the only 0 that we have is G, and then the rest of it is 1. And then for example, for the number 1, we have 1 1 only for B, C, and then the rest of it is 0. So that is how we show the display pattern on the 7-segment display. And then the next is the conversion process. How does it process? So step number 1, the decoder receives a 4-bit binary combination. For example, we have 0011 for decimal 3. And then step 2, we have internal combinational logic circuits derived via Boolean algebra or K-maps decode this specific input. And then for step 3, the specific output lines corresponding to that number are energized. And then here is the example. For input 0011, which is number 3, outputs A, B, C, D, and G turn on, while E and F stay off, rendering the shape of a 3 on the hardware, which is the 7 segments. So where we can see the 7 segments. So here is the real world application. So here the example is for digital alarm clock or microwave timer. So how does it apply? The internal microcontroller tracks time in binary or BCD format to show the time. For example, 12:30 to a user. It routes the BCD data through separate decoders to activate the individual numeric display panels on the device's face. So why is it essential? It is for reducing the complexity of microchip programming by offloading display illumination logic to dedicated hardware. So lastly is the conclusion and summary. So BCD simplifies decimal human-machine interfacing, and then the decoder acts as the translation layer, converting 4 input data lines to 7 specific output display lines. So it is essential for readable readouts in consumers' electronics. So that is all from me. Thank you so much for your time and also attention.